In this video, we're going to find the slope of a line using the slope formula and the coordinate plane. So what is slope? Slope describes the steepness of a line by comparing the vertical rise to the horizontal run. So as we take a look at the blue and orange line and try to compare what their steepness looks like. So we can see that the orange line looks a little flatter than the blue line. The blue line looks more steep. So we could talk about how the slopes compare to one another. The blue line would be considered more steep than the orange line. In other words, the blue line would have a larger value of slope than the orange line would. The ways we're going to calculate slope are going to be on the coordinate plane by counting that vertical rise and horizontal run, or using the slope formula to calculate the vertical rise and horizontal run. The slope formula is here. We have m that represents the slope. Whenever you see that m in a linear equation, that m represents the slope. And we have 2 points on our line. So x1, y1 would be one set of coordinates. So for example, this point here could be a point on the blue line. And x2, y2 is another point. So we just choose another point on that blue line and we can count that. Let's take a look at some examples. Alright, so I have the line here graphed on the coordinate plane. I have the point 2, 3, and 8, 6. The horizontal run is from left to right. The vertical rise is up and down. So using the rise and the run to find the slope, the vertical rise goes on top, the run goes on bottom. So we say the slope is the rise over the run. So let's take a look at how that looks on the coordinate plane. If I want to start at the point 2, 3 and end on 8, 6 on this line, I'm going to count up and then over. So from this point, I'm going to count 1, 2, 3 spaces up. So the rise is a positive 3. From there, I'm going to count over 1, 2, 3, 4, 5, 6. So my run is a positive 6. From that, I can use the rise and the run to find my slope is 3 over 6. But I have to simplify. To simplify that ratio, I get 1/2. So the slope from 2, 3 to 8, 6 is 1/2. What if we wanted to go the other way? What if I wanted to go from 8, 6 to 2, 3? Does it have the same steepness if I go the other way? So if I start at this point, I could go down. So this time my rise is -3 because I'm going down. So I've counted 1, 2, 3 boxes down. Now I'm going to count over to the left. 1, 2, 3, 4, 5, 6 to the left, which makes the run value -6. Well, if my slope is rise over run, I'm going to have the -3 on top and the -6 on bottom. That gives me a negative over a negative, which makes a positive 1/2. So notice I got the same slope either way. It doesn't matter which point you count from. You'll get the same number when you simplify the slope. Let's take a look at the formula. Well, we are going to use y2 minus y1, x2 minus x1. Our 2, 3 is going to be our x1 and y1, just our first point, and 8, 6 is going to be x2, y2, our second point. The little 1s and 2s just mean that that's my first one and that's my second one. So that's going to look like y2, which is the y value of the second point, minus y1, so that's where we get the 6 minus 3, over x2, which means the x from the second point, minus x1, which is the x from the first point, which is where I get 8 minus 2. That gives me 6 minus 3 on top, which is 3. 8 minus 2, which is 6. Notice that looks a lot like the rise over the run. And that simplifies to 1/2. So even with the formula, I get that same slope. So you can count it on the graph or use the formula. What if I labeled my points the other direction? What if this was my second point and this was my first point? I should expect to get the same slope. I have 3 minus 6 and 2 minus 8 this time. Notice this looks exactly like what I did here. I'll get 3 minus 6, which is negative 3, 2 minus 8, which is a negative 6, which gives me a positive 1/2 when I simplify it. All right, let's take a look at another example and calculate that slope. So I have line JK, and I want to find the slope of this line. I know on the graph I can find the rise and the run. So if I start at J, I'm going to rise 1, 2, 3, 4, 5 up. That means that my rise is 5. And I'm going to count over 1, 2, 3, 4, which makes my run a positive 4. So I know that my slope should be 5 over 4. Now let's use the formula. If J is my first point and K is my second point, I'm just getting the coordinates from the graph. So this is negative 1, negative 2 for point J. Point K is positive 3, positive 3. So those are the coordinate values of each one of those points. When I plug in those values to the slope formula, I get 3 minus a negative 2. Those are my y values from both of my points, over 3 minus a negative 1, the x values from both of my points. I get 5 over 4, which is the slope. For this next example, I'm going to count from M to L on this one. So starting at M, I would go up. So 1, 2, 3, 4, 5, 6. So my rise is a positive 6. From here, I'm going to count over 1, 2, 3. So notice I went to the left, and so my run was a negative 3. So now I need to put these together for my slope, which means I'll get a 6 over negative 3. So 6 divided by negative 3 should give me a slope of negative 2. Let's use the formula to verify that. So my point L is at negative 2, positive 3. Point M is at positive 1, negative 3. I have my two y values from the points. y2 is negative 3. y1 is positive 3. x2 is positive 1. x1 is negative 2. So I'm just plugging those in for those values. Negative 3 minus 3 is a negative 6. 1 minus a negative 2 is a positive 3. When I divide those, I get negative 2, which is what I got when I did my rise over the run on the graph. You should get the same number, no matter if you do it on the graph or if you do it with the formula. What about here? If I'm going to count the slope, I need to count the rise over the run. Notice here, there is no rise. So my run is 7. So if I have no rise, that means that value is 0. So I have 0 divided by 7, which is 0. Let's verify that with the graph. Well, when I plug in those points, I get that 0 rise over 7 for the run, which is 0. This line has a slope of 0. All horizontal lines will have a slope of 0. Next, let's take a look at a vertical line. If I were to count the rise and the run for this line, I would have a rise of negative 5, but I wouldn't have a value for the run. The value for the run is 0. So I have 5 divided by 0. When I divide by 0, that is undefined. So the slope for a vertical line is undefined because I'm dividing by 0. So let's summarize a little bit on the shape of graphs and whether they're going to have positive or negative slopes. We always read a graph from left to right. So as I scan this graph, notice how this graph is rising. So that means it has a positive slope. So as we go up the hill, as we read the graph, that's a positive slope. As we read the graph and it's going down, that's going to have a negative slope. This is going to be a way to check your work. If the number you get at the end is positive, make sure that it matches the shape of your graph, that it should be rising. If you get a negative value for your slope, make sure the line you're looking at is falling. All horizontal lines should have a 0 slope. All vertical lines should have an undefined slope. I want you to pause here and try these examples on your own. Try finding the slope either by the graph or with the formula first. Try to label the points x1, y1, x2, y2, so that you know exactly where to put those in the formula. So label your first and second points, your x1, y1, x2, y2. Pause here so you can try these first. All right, take a second to check your work. Notice how this line is rising, and so we have a positive slope, and we end up with 1/3. Notice how this line is falling as we read that graph from left to right, so our slope is negative. This line is vertical and has a slope of undefined. This line is horizontal and has a slope of 0.